everyone. Welcome to the panel today. We're going to have some very interesting discussions on delegated proof of stake versus proof of stake. So we'll start off with introductions. I'm Aparna. I was the previous founder of education at Blockchain at Berkeley, and currently I'm the co-founder of Mechanism Labs. So do we want to go through?
Sure. My name is Luke. I'm a senior developer at Decred. We are a proof of work, proof of stake cryptocurrency, a digital currency, not necessarily a smart contract platform.
Hi, I'm Oded. I'm replacing Uriel from ORBS. I'm the chief architect of ORBS. We're a platform for basically for consumer scale blockchain.
I'm David Moss. I'm with StrongBlock, not with TrueBlock, despite what it says up there. I was the SVP at Block 1, employee number 2 to build EOS, and now I have a stealth startup called StrongBlock.
Hi, I'm Chris Lee, and I'm the CTO of Thunder Token. Thunder Token is a public blockchain that does high performance and with fast confirmations.
Cool. So 2018 has been a lot of different scaling solutions, a lot of different projects talking about proof of stake. So something I'm just curious about is, why did your project choose to have proof of stake?
Sure, I'll kick it off. So Decred is a hybrid proof of work, proof of stake cryptocurrency, and the reason that we added proof of stake has a lot to do with the experience that the original Decred developers had back when they were Bitcoin developers. They built BTC Suite, which is the Golang Bitcoin implementation, and during that process, they just saw a lot of these issues firsthand with informal governance, mainly being miner centralization, the miners having too much power. There's no way to gauge what the Bitcoin holders wanted. It's the developers making all the decisions. And then the introduction of VC money into funding the dev teams creates potential conflicts of interest where the long-term interest of the VCs might not necessarily align with the interest of the Bitcoin holders. So we use proof of work for the underlying security and then add a proof of stake layer to get the governance and to be able to align incentives via skin in the game.
Cool.
So I think the main issue here is about alignment, and the choice to go for proof of stake. Well, there are many flavors of proof of stake, and there's huge differences between them. And it's mainly about the choice not to go for proof of work, which we believe is just not sustainable as a long-term solution. So we chose to go with proof of stake, and then found out the flavor that fits our belief. But there really is so much differences between different proof of stake solutions.
Yeah, on delegated proof of stake, which is what I've been working on for the last year and a half, the way that we see it is by having basically the idea of delegated proof of stake is that there are people who have votes, and they send them to the various delegates. In EOS, there's 21 block producers and around 30 to 40 standbys. And in that type of an environment, what you get is a really nice combination of voting control, delegation, and speed of consensus. You don't have 50,000 nodes like you have in Ethereum. And I spent a fair amount of time in Ethereum as well, working on in that environment. And this is much cleaner, faster, feeless, and that's one of the things that we found that's really nice in delegated proof of stake, is that we're able to really get the overall cost down.
Thunder use proof of stake, and the reason Thunder use proof of stake, Thunder actually can use proof of work as well, but we choose proof of stake to be performance better, because proof of stake we can do asynchronous transactions a lot faster than the traditional proof of work, and also proof of work burn a lot of electricity, and then that's not ideal.
That's really interesting. So it sounds like I'm hearing proof of stake for performance or energy sustainability or governance. So something I'd like to dig in a little more deeper into is, how do you see proof of stake or delegated proof of stake helping with governance? Yeah.
Sure. So proof of stake, it allows for coin voting, right? So it allows you to get stakeholder input, to allow stakeholders to make decisions, and those decisions are being made based on the amount of skin that they have in the game, which I think is really important in aligning these long-term interests. And ultimately, it's the overall bigger picture is just intermediating out these trusted third parties, right? The traditional fiat system relies on a tremendous amount of trust, and the whole point of using these governance systems is so that we can get rid of the trusted third parties and turn them into open source code.
Do any of you want to add to that?
Sure, yeah. One of the things that I think governance is actually going to be the future of proof of stake and delegated proof of stake. I think that's the area that is the most early or nascent here, but it's also the area that can stand the most growth. One of the big things that we look at is, can you get most of this? Let's say the Pareto principle of 80-20. Can you get most of governance into smart contracts so that most of the things can be adjudicated within the community and within automated code? Basically, can you get it into code, and then the rest of it, then it can be taken off-chain or even on-chain to do arbitration, et cetera. And so I think that the governance area is the most interesting within PoS and DPoS, is that as we get better at creating constitutions, creating smart contracts where most of the stuff can be done automated. eBay, for example, does about 80% of their arbitration and dispute stuff automated using AI and a number of other different things. I think that's where governance on the blockchain, especially with PoS and DPoS, is heading.
Gotcha. So who do you currently see as the people who are building out these governance models? Are they engineers? What's the current scene like, and what do you anticipate?
So I would say that until pretty recently, the governance models were built by engineers, and but I think it doesn't have a lot of effect on what we're going to see in the future, because the whole issue of governance schemes, it's quickly evolving. And well, actually, look at it. If you look at the nation-state governance, it's been evolving for thousands of years, and corporate governance have been evolving for hundreds of years. And it's still evolving, because corporate governance today is not the way it used to be 20 years ago. And I think the main issue that we need to anticipate is for governance schemes to keep evolving, and so we need to think about how we provide flexible governance and allow dApps to have their own governance and do some trial and error, and try to make it more interesting by trying stuff out.
Yeah, I'll add a little bit to that. So a lot of these blockchains are experimenting with these governance layers right now. And I think one thing that we want to keep in mind is that governance, it should be context specific. Certain governance structures may work on one blockchain that won't work on another. An example of this would be this plutocracy argument. There's this big debate between on-chain versus off-chain governance, and that on-chain will lead to a plutocracy, where in a blockchain such as Ethereum, where you have two different classes of users, like dApp users who want to minimize the cost of gas, and then Ethereum holders who want to maximize the price of ETH, you have two incentive structures that are just fundamentally opposed. So in that context, a plutocracy argument might make sense, because if one group acts in their own self-interest, it's to the detriment of the other group. Whereas in a cryptocurrency like Decred, it's not the same scenario. We are a pure digital currency, right? So the interest of the largest Decred stakeholders and the smallest Decred stakeholders, they're the same, to maximize network value. So calling a cryptocurrency like Decred a plutocracy would be similar to calling a company a plutocracy. Like, you can do that, but these incentive structures were put in place in order to maximize value creation. So I think we just need to be just keep that in mind as we're talking about this governance, that not to take conclusions and apply them to blanket statements across the entire ecosystem.
Yeah, I'd like to add to that. You hit on something very important, is the incentivization models. And one of the big issues right now is, if you're looking at, again, I'm going to have to take EOS because I've been immersed in that for the last year and a half, as I said. The incentivization model encourages block producers to essentially vote on keeping themselves in and vote on keeping maybe their friends in. And in that kind of a model, the incentivization ends up not supporting the dApp developers, because there's some problems right now with noisy neighbors, or problems right now with needing to gray list people who are over over abusing their privileges on the net. And so there are a lot of things that in the incentivization models mixed in with practical solutions. I also like that point that you made about practical solutions. We don't want to have, you don't want to have, the United States Constitution is not going to go on a blockchain right now. We're not ready for that. That's going to evolve over quite a period of time. What we really need is simple ability for you and I to enter into a contract. Like, if I'm driving and you're the Uber rider, then we need to be able to enter into that contract and maybe not have Uber, the centralized part, because it's decentralized when you and I are riding, right? But it's not decentralized when Uber is collecting all the data and collecting all of the percentages and everything. But if it's just between you and I, what we need is a good, solid arbitration smart contract. If I take you to the wrong place and say, well, you're going to pay me anyway, we need some way of resolving those kinds of simple, real-world disputes.
That's really interesting. So switching gears for a sec away from governance, a lot of you talked about how you use proof of stake for different scalability purposes. Now, what are your thoughts on Vitalik's trilemma, where he sort of talks about this trade-off between scalability, decentralization, and security?
Oh, you mean fast, cheap, reliable, pick
Sure.
two?
Exactly.
Yeah, that's the classic thing. Do you want to?
Yeah, I do. Well, I actually do see that this trilemma actually very difficult to solve three at the same time. In Thunder, the way we do it is basically we have a structured infrastructure to help to get the scalability and the security. And then some would say that we're less decentralized, but we probably choose to do the decentralized way in a more democratic. Well, basically, we allow the committee member to elect the accelerator, and that kind of way to get them more decentralized. Other people can participate in the game. But at the same time, I do think that it's actually very hard to do both like decentralized and also high performance and secure at the same time.
Yeah, so a lot of pure proof of stake protocols are using proof of stake in order to increase scalability. We're doing it a little bit different. We're relying on the Lightning Network Layer 2 solutions to increase our transaction throughput, and we're really just relying on proof of stake for that governance layer, but also to add some additional security benefits to pure proof of work. So for example, a 51% attack in Decred is an order of magnitude more expensive than in a pure proof of work cryptocurrency, because not only do you have to acquire the hash power, but you also have to acquire the stake in order to validate that hash power. So the hybrid model gives you some interesting security benefits as well.
Yeah, I think one of the other, again, looking at that, again, I completely agree. The fast, cheap, reliable, pick two, that's kind of a classic computer science issue when you're trying to put things together. But I think when you're talking about block producers and nodes, whatever you want to call them, validators, et cetera, the whole idea is to try to figure out not only how to incentivize them, but how to disincentivize them from bad behavior. And I think that that's what you're talking about. Some of the things that Decred is doing is figuring out how to make it so that you're rewarded very strongly for being a good actor, by not colluding, by not doing certain other things. And so you end up having such big penalties for not cooperating in a decentralized manner that it makes it difficult for you to actually continue to participate.
Yeah, absolutely. In Decred, it's very difficult to go against what the stakeholders want. They are the people with the ultimate authority of the direction of the protocol, of which blocks get validated. So yes. So
how do you prevent then collusion among those the stakeholders? Because that's kind of one of the key things that keeps coming up is that they can do backdoor deals and elect each other if there are a certain number of votes, et cetera, that they can do, token holders, et cetera.
Yeah, absolutely. So we don't have any type of elections. Delegated proof of stake is a little bit different because you do have the elections of the actual validators, right?
Yeah, literally almost every block round, every time.
Yeah, so the way that it works in Decred is when you stake your Decred, you purchase what we call tickets. And every block, proof of work block that gets mined, 5 tickets are drawn from the ticket pool to validate the validity of that chain. And so there's the opportunity for collusion is a little bit different. And ultimately, since your ability to influence the network is directly proportional to the amount of Decred you own, your interests are aligned to maximize the value of that Decred, not necessarily to... so for example, when you have the ability to delegate your vote to somebody else, you now create the potential for this perverse incentive where the person you delegated your vote to, the amount of authority they have is not now directly proportional to the skin in the game they have. So you create these weird incentive structures where you can get into some tricky situations. And I think we just try to avoid that altogether.
Okay. So when talking about like proof of stake, one unresolved issue seems to be the sort of colluding of different participants. What are other unresolved issues that you see?
Well, I think in general, one of the things that we're seeing on mainnets, and this is, I'm going to go on a quick little rant here on mainnets, is that while I agree that public mainnets are a very good thing in a number of different ways to be able to build apps on, you end up running into a couple of different problems. One is security, and we go back to fast, cheap, reliable, and reliable is security and other things. It's harder with elected block producers with no head to figure out, no central authority to figure out exactly whether or not they are colluding. It's also harder to figure out whether or not they have all of the equipment that they need. Are they the weak link in the chain? It's also harder to prevent things like noisy neighbors. And by noisy neighbors, I mean an example that was on the EOS network just the last couple of months. There's a group called Block Twitter, and they don't really actually tweet anything except the following phrase: "We love BM." Now, BM is Bytemaster, most likely. That's Dan Larimer, my former colleague's. That's his handle in China, or it could be Burning Man, or it could be something that we don't want to talk about. But the whole idea is that they inundated the blockchain so bad, the EOS mainnet so bad that whenever they were running that and just literally slamming it using a bot, everybody else's productivity suffered, and they were unable to run things through the chain. And so this is a kind of it's an unspoken thing. But what happened was that the block producers literally had to get together and decide to gray list that particular person that was running these things. Now the problem is that now we get into constitutional issues. Is that, well, who gets the right to silence the speech of someone else? Is as crazy as their speech would be. If we're going back to United States First Amendment rights, it's like the right to free speech is that you can say "we love BM" and stand on a street corner and say that forever, right? So what we're trying to figure out is, well, how do we actually make that work going forward, and how do we reconcile that? But that's one of the big issues, is the noisy neighbor problem then really becomes a constitutional crisis.
Yeah, I think when kind of power is consolidated in a small number of validators, you do just run into those issues naturally. There's going to be the collusion and the fighting and stuff like that. As far as Decred goes, the main proof of stake issues that we're working through right now is just really just implementing figuring out the finer details of our governance model. So in Decred, 10% of every block reward gets set off to the side and put into a network treasury. And Politeia is our proposal system. It's our effort to hand that network treasury over to the Decred stakeholders. And we're working through a lot of the finer details of how exactly that will work, what the processes and procedures will be. And eventually we want to turn that network treasury into a smart contract so it's completely automated, and Decred at that point would be a DAO built into the protocol layer.
Yeah, one thing I'm working on these proof of stake systems, a very interesting observation was that when we're doing the proof of work, and then typically when the price goes up for the coin, and then the gain, the miner gain will go up, and then there will be more miner coming in, and then the hash difficulty will went up, and then essentially we become the more efficient miner will be the one that will able to stay in the game. And then there's a mechanism allow the more efficient miner to profitable in the proof of work system. And I think we are thinking is that can we achieve the same thing in the proof of stake system? Because proof of stake, you have the problem that whatever parameter you choose, you are likely to be wrong, because the price adjusts like couple hundred times, and then when the price go really high up, and then maybe a lot of people want to jump in and become the validators, and because the gain was high. And then I think it's very interesting, how do we actually design from the protocol level, allow this kind of more efficient and people to become the validators and become the miner they can gain from the systems. And then that's one of our design goal. And a lot of these when I'm looking at the proof of delegate proof of stake, one problem I see is that it's actually not the delegate person that they gain this by reputations, but it's actually not proportional to their stake shares, and then it's not in the protocol that they describe how they get punished. It's outside the protocol. That's why you create this weird situation. Some people get a lot of fame, or get a lot of people like them, and that's why they become the validators. But the stake in the game is not proportional, and then that creates problems.
I would say that there's a few techniques that I would want to see more to resolve these challenges, the challenges of collusion and the challenges of misalignment and things like that. And I think that there are a couple of networks that are using, that gave away the idea of anonymity, and I think that giving that up really does simplify, it opens the door to a lot of techniques that you can use to limit the ability of many players to collude. Because you know who's behind them to some extent.
You're talking about KYC and attestation then?
Yeah, but a bit beyond that, you can use that to actually create some liability of the stakeholders to comply with a set of rules or a constitution, and to some extent, and of course it's very limited, to actually expect them to play by the rules. And we see that on EOS, that the rules disallow the block producers to collude, but it's really, really hard to prevent that. And another technique which a couple of networks are using, mostly for the real-time production of blocks, is randomization instead of delegation. And I personally believe this has a lot of merit and could really resolve a lot of issues.
Yeah, that's great. Great point. The KYC and attestation thing, if you do that up front, and then block producers are less anonymous now, in some cases they still are publishing who they are, but they're not publishing who it is that they're actually working with behind the scenes. But yeah, I really agree. I think one of the things that I'm seeing is that in DPoS, for example, again, the area that I know the most right now, what you have is you have a schedule of block producers, and they're randomly picked, but they're always going to be 126, basically 12 blocks per round, half a second per block, so it's basically 6 seconds goes around to all 21. That's the process for doing that. But it's a relatively predictable thing. If you go to EOS Network Monitor, you can see the next block producer up. Next on the board is going to be so-and-so. What if it were more, random or chaos monkey? What if there weren't even 21? What if you were only 21 a particular round, and all of a sudden, bam, 4 of them got taken out, and somebody else was the other one? More randomness, I think, also gives a better incentive, because then you have an incentive to act better and be a part of it. Plus, you can't reliably predict how you're going to get those blocks paid for every round.
Well, this is also one of those unresolved issues in proof-of-stake protocols in general, is this predictability problem, like this ability to predict when a stake is going to be called to validate, and then the attacks that can go along with that. So finding that source of randomness is a bit difficult. What's interesting about Decred is we use the block hash from the proof-of-work side as a source of randomness for selecting the tickets.
Yeah, and I think that's especially the idea of randomness is, where does that come from? I mean, that's one of the things that we're dealing with at StrongBlock is, looking at the, you're aware, everybody's aware, well, not everybody's aware of, in 2014, the NIST libraries that underline P256, the elliptic curve protocol that everybody it uses for all of the ERC20 tokens, that was found to have a backdoor, and it was the random number generator that the NSA had put in, and it turns out that it wasn't really quite so random. And so the idea is randomness has always been an issue, and how do you ensure that? We're looking more at curve 25519 and a couple of other things to be able to ensure that we can't have a corruptible randomness generator. But randomness in most cases is, as you said, is not as random as you think.
So that's quite interesting, because randomness is often used as a way to deal with this whole predictability issue. But another issue that often proof-of-stake protocols are criticized of having is forking. So what are your thoughts on the cap theorem, where in the case of a network partition, your chain has to choose between either consistency or availability? So to elaborate a little bit, what I mean is, in the case of people being partitioned, how do you think about dealing with tiny microforks that eventually converge, Or do you want to ensure that your network is always like, everyone has the same view?
Sure. So since we rely on proof of work for the fundamental block discovery mechanism, we're choosing availability over consistency, right? And so these temporary forks, they are going to happen. The block reorgs are occasionally going to happen. One interesting thing about the hybrid model is that so far we've only had a block or a temporary fork of a depth of 1 block so far. So I think there are things that you can do to kind of combat that a little bit, but the issues with the pure proof of stake protocols are a little bit different. So I'll let one of y'all elaborate on that.
In Thunder, that traditional Thunder protocol doesn't allow fork. Basically, we have accelerators, and that accelerator will be the one that serializes all transactions. And then we have some recent research that we're able to do multiple accelerators, and that one will have a limited depth of fork. But the way we deal with it is you actually don't see those fork as a stable point, and then when past the fork point, the limited depth, and then those will be the one that becomes stable.
Well, I just want to add that from the practical point of view for real-world applications, the concept of eventual consistency, that you could have a fork that's very deep and then it gets replaced, is really a problem from actually the business use cases. But the real-world statistics show that even on Bitcoin, after 10 years, I think the deepest fork that ever existed was 2 blocks. So we can limit that. We can offer finality after 1 or 2 blocks deep. I think if we don't have anonymity in block production, that means that it's actually even much safer than the two blocks fork that we had on Bitcoin. And so offering finality after a couple of blocks, or 3 at most, is absolutely reasonable, and it does solve a big problem.
Yeah, I agree. And that's one you came up. You used a great term that I really like, is the eventual consistency. And that's going back, like Amazon Web Services, for example, promised on S3 buckets that they would have eventual consistency. And when it first started off, it was 24 hours. It's like, okay, well, don't plan on getting to the data for 24 hours. But I think that there's a combination of availability and consistency and consensus and everything else that kind of is the sweet spot for those things. And I think one of the things is to get the speed that you want. In some cases, maybe you need to do off-chain or side-chain processing and then go for eventual consistency on the main chain by processing some of those, using those as queues. I know that Loom and GoChain and a couple of others are using those things, or even putting a layer like with Kafka or something like that in there that has an X.509Q processor that takes the data in and then pushes it out eventually and gets it in there. But I think microforks, and I think that was the basic question, is that microforks do happen all the time. It's just that they literally just disappear. You never even really know about them because somebody gets off, somebody gets behind, somebody went into the server room and flipped the switch the wrong way and it went off for a little bit and they have to catch up, and so somebody else is forking a little bit, and those things all in a good consensus model basically all reconcile themselves, and there isn't a big problem. You don't end up having the, oh wow, we've got to take a snapshot and start a new chain. That's something in DPoS and PoS that I don't see happening.
Okay, so microforks, it sounds like, might be okay, but what about macroforks, like hard forks, soft forks? What are your thoughts on governance models that incentivize not forking, or how do you deal with hard forks?
I think we should just embrace it. It's something that I don't see you can practically avoid. And putting a lot of governance in the smart contract and stuff, I thought about those, but it seems like just make things super complicated, and then you might not able to prevent the hard fork anyway, like when you do some protocol upgrade. I think it's a healthy thing that protocol will able to evolve and change and for the better eventually. So hard fork is kind of required.
I think the most serious problem of hard forks, and it really relates to what Luke said earlier, is when you have the conflict between 2 types of stakeholders. And I think that exists in most platforms that we see today, that A lot of time, the big stake owners are not the users of the system, and the infrastructure players could be, in the case of EOS, for example, the block producers are not dApps, and they have different interests. I think these conflicts are the main reason for forks, because naturally, everybody wants the network not to fork. Everybody has an interest in having a single network that enjoys some advantage to size. Our approach at ORBS is to provide a level of autonomy. So I'm not getting too much into the depth of it, but on ORBS, every dApp has its own virtual chain. So we use the concept of virtualization, like in cloud computing. And so within the dApp's own virtual chain, it can make governance decisions and set up its own governance as long as it doesn't affect the others. The interests of the infrastructure players are just, they don't come at conflict of the dApp because they just operate in different realms. And hopefully that will be more stable.
Yeah, so Decred actually has a really interesting mechanism for dealing with these contentious minority hard forks. So because of the hybrid model, there's essentially a way for the stakeholders to attack the minority chain if they don't want it to exist. So like I said before, when you stake your Decred, you purchase what we call tickets. And every proof of work block that gets mined has to draws 5 tickets from the ticket pool, and those tickets vote on the validity of that chain. And so the way that those tickets are drawn is really important. They're drawn in a pseudo-random deterministic fashion using that block hash as the source of randomness. So the same block hash will result in the same 5 tickets being drawn every time. And if those tickets don't validate that chain, then that proof of work block is no longer any good. There's nothing that the miner can do with it. Essentially, because if he tries to resubmit it, the same 5 tickets will get drawn, and then you'll get the same outcome. So that miner has to throw that block away and mine a brand new block, try and draw 5 more tickets in order to get his block added onto the chain. And so it ends up being very, very computationally expensive because a lot of those resources just get wasted. And the way the numbers work out is if a minority hard fork has 25% stakeholder approval, the proof of work miners will have to mine roughly 10 blocks to get 1 block added onto the chain. And so it becomes extremely expensive to maintain that for any duration of time. And so it's an interesting mechanism that makes it difficult to go against what the stakeholders want in Decred.
Yeah, great. It's one of the things that's fantastic. Again, you and I have talked about this before, and I love the way that that's put together because you're looking on striking a balance. One of the things that I started emphasizing a little bit earlier too is that we are kind of stuck on mainnet monoculture, and the fact that we just have to have you get this code and you have a mainnet. When we were building EOS, we very specifically gave it an MIT open source license, and if anybody's ever read that, it's 3 paragraphs, and the first paragraph is you can use it to do whatever the heck you want. The problem you have is that when you're also using it, you've got to figure out, well, do you use the EOS token, no token, your own token? Those are all possibilities the way that we built it. So what does that actually mean in the real world? It means that a hard fork could be that you take the code and you go out there and you build your own semi-public, semi-private chain that you're allowing to hook back into the main chain via inter-blockchain communication, light Merkle proofs, et cetera. And so the idea is that when we're talking about forks, there's another way to go, which is not just try to suppress forks in a mainnet, but as you talked about, embracing forks and say, well, what if there's somebody else who wants to start another project that actually uses the original open source code? That's what it's there for. And then how do you achieve decentralization in that kind of an environment? And do you use the EOS token? Do you use some other token? Those are some of the things that we're pondering right now what we're working on.
Yeah, I think there's an important distinction there that you have to make, though. The ability to fork a code base, that's great, right? It gives a non-violent way to exit, and ultimately lets the market be the arbitrator of the dispute, so it encourages competition and drives innovation. The forks that you want to avoid are the forks that you talked about, where you have a contentious minority that then tries to essentially attack the main chain in some way, like we saw with Bitcoin Cash. There's fights over hash power, there's fights over the Bitcoin brand, and it just causes a tremendous amount of disturbance in the ecosystem. And that's really what you want to try to avoid.
Yeah, completely agree.
Yeah. I think if you have stakeholders, they want to fork and then they want to modify the source code and create their own version, there's no way you can prevent that. I think the assumption you have some technicality way to prevent that from happening is assuming that everybody running the same version of the same kind of source code. But if they change the source code, they can do whatever they want, right?
So you brought up a very interesting point of like forking code bases. Do you think there are going to exist public and private mainnets? And what are your sort of thoughts on cross-purpose governance between these? And
Yes, the answer is yes. They're going to. There already are, and you know, if you look at the Ethereum, you've got a lot of them are being made backward compatible. GoChain and Loom are two specific examples where they run all the same Solidity code and everything else is ready to go, but they've added some additional features to speed things up. So they've essentially forked it, but made it backward compatible so that you can actually still run your mainnet code against the private code. Then on the other hand, it's like, you know, if you are trying to solve a particular problem where you don't necessarily want everybody in the world to be able to go out there and do a block explorer against your chain, then you have to, then that's where you're going to start seeing things. I know that people, a lot of companies are starting to look towards doing that, but then you end up having Hyperledger Fabric, which is, you know, really not decentralized, and so how do you solve the decentralization problem? Well, if you're using DPoS, then you've actually got that capability because you can launch and mesh decentralized block producers with no head in a separate environment. There's some governance things that have to be worked out for that.
Yeah, so I think that this also depends a lot on what like a company is going to want to use a private blockchain for, right? If they're just looking for a data authentication system, then I don't necessarily think they need a full blockchain for that. What they probably want is maybe like a time-ordered file system that is time-stamped onto a blockchain so that all the data is cryptographically verifiable. That's essentially what we're building with our proposal system. That's basically what it is. It is a system for versioning data and then time-stamping that data, so Merkling it down and stamping the Merkle root onto a blockchain for all that data and tracking all the changes so everything is verifiable in a cryptographic manner. And we're actually seeing it being used in Brazil for exactly this. They're using it, a company is using it to track political donations and making them verifiable on a blockchain for future reference. So I think before a company goes the full private blockchain route, they need to take a look at what exactly they want to use a blockchain for and maybe try and start with just some something not full-blown blockchain unless they absolutely need it.
Yeah, just to make sure that you're not trying to use a distributed, basically it's a distributed database at that point, not a real blockchain.
Exactly,
yeah. Okay. Oh.
I'll just say that I think that a lot of companies today are underestimating the cost of actually securing their own private blockchains. And this pretty much resembles the debate that we had 10 years ago about private clouds. And a lot of companies launched their private clouds, and today they're going out of fashion. So, because people realize, and it took a while for them to realize that it's just not worth it.
Yeah, I think at various development stages, there will be certainly some kind of like testbed environment to test certain features versus like whether code is stable and whether the failover can actually happen and stuff like that. There definitely will be a private chain somehow, but it's just like how do we actually get a more public test version like the testnet something to run those code bases.
Gotcha. So Luke, you touched upon a very interesting point of how people should maybe build blockchains once they have use cases in mind. So I'm curious to hear everyone else's thoughts on should you first have a use case in mind and then build a blockchain, or the other way around? And if it's the former, what sort of use cases are you thinking of enabling?
Sure, I'll start this one. So in order to know the trade-offs that you're willing to make, you have to know the use case first beforehand, right? And so with Decred, we are trying to be a store value, a censorship-resistant form of digital money. And so for that use case, we need the utmost security and decentralization on the blockchain layer. And so that's what we're going after, and that's what we prioritize for.
Yeah, so our approach is extremely to walk through the use cases. Basically, we think trying to come up with practical solutions, it's all about trade-offs, and the only way to make trade-offs is not only to have a use case in mind, but to work hand in hand with design partners that actually need to deploy a solution soon, and that's actually the only way we're working.
Yeah, I mean, look, distributed ledger technology, is a really cool invention. 20 years ago when Nick Szabo and Ian Grigg came up with the basic concept of being able to have witnesses and everything, that was a really great solution to, I'm not sure which problem, replacing auditors. What was the actual solution there? So it was a solution. Ethereum is also a solution, not necessarily with a defined problem. And even EOS and BitShares and Steemit before it are solutions to the problem of how do I make an independent, decoupled operating system for a blockchain so I can write more apps. So that's the problem that it was solving. Actual business, real use cases, that's what I think is really the future here. And you have to start off by defining what the use cases are and figure out, is it supply chain, is it medical data, is it provenance of art or food or anything like that, and then figure out, well, what's the right solution or combination of solutions, because you can't put everything on a blockchain. It just doesn't make any sense. It's like, well, let's put everything in the cloud like you were talking about. Let's do our own private cloud, and everybody goes enthusiastically because they get budgets for it because it's a buzzword. But really, we just need to figure out what are the business problems that need to be solved. And business can be, non-governmental organizations, community efforts, the UN, whatever. As long as we define what it is we want to do and how decentralized we want it to be, then we can actually figure out what the right appropriate technology is.
So for Thunder, we are a Ethereum compatible public blockchain. So we do see that Ethereum have some performance limits, and like just one CryptoKitty can like bottle down the whole Ethereum network. So we are set up to do a very high performance and very fast confirmation time public blockchain. We think that will definitely serve some purpose.
So we have a couple more minutes. Are there any questions from the audience?
You mean Naval Ravikant? Yeah. Really absolutely respect him, and I think that right now, this is very early days for all of this stuff. I mean, EOS has been out for 4 months, and there are no major applications running on it yet. As a matter of fact, there are no major applications running on DPoS in general. EOS is touting the fact that they've got an extraordinary, more transactions on EOS than any other blockchain. That's like saying, well, there's more people in this room than there are in the world. It's just like, what's the comparison? I don't quite get that. So it is early. The mechanisms are there.
Do you agree or disagree with his statement? That's really,
yeah.
I really want to know, do you agree or disagree?
You mean, so the question is, are they not ready?
Is it not proven tech? He was saying POW is proven, POS and DPoS and anything else is not proven.
So is POW proven? Well,
but it works for what? It works for generating Bitcoin.
Well,
do you disagree or agree with his opinion on his? It sounds like you disagree.
I'm doing I'm going to do a Schrodinger on this. I'm going to say I agree and disagree at the same time, because I think that there's right now, DPoS and PoS are out there working. People are working with them, and frankly, there's a whole ton of applications that are actually running, actually working on it. It's not an experiment, because there's actually up and running software that's in that realm. Has it not been adopted yet? That's different.
I think that if we take our time machine and go 50 years into the future and look back at what we're doing today in 2018, we'd say that both proof of stake and proof of work, the way we use it today, are not working. And these technologies need to evolve. But the other thing to remember is that the usage is also evolving. And proof of work works today for the very limited use that people are doing out of it. If Visa switched to a proof of work system today, it would crash on the first second. And
this is a very interesting discussion, and let's have more questions by the side. Let's have the next talk right now. Yeah. We're out of time, so.
Thanks, everybody.
Thank you.